So in the last lecture, we saw the numericals in which the system having same acceleration in value and in the sense of motion, and we got the answer. Okay. So for all system in which the sense of acceleration of every body is same, that is, we don't have multiple acceleration, can be solved with the help of a concept of system. Okay. So I will begin with the same Atwood machine that we started with. I hope you remember the Atwood machine, right? So do you guys remember this machine?
Yes.
Now you may be wondering, sir, why this is called machine? The machine, the benefit of machine is that with less effort we can do, or we can pull more load, right? Like there is something called mechanical advantage. Okay. So when you study in class 9th to 10th, the first level machine, a machine will have some mechanical advantage. Okay. So a pulley and block system can be used for the advantage, but we'll see later on how the advantage is used. Now, if you remember this question, out of the two blocks, one will go up and one will go down, right? There is no choice. If if you look at M2 and M1, so one has to go up and one has to go down. Am I right, guys? So do you realize that the acceleration value of both the blocks are going to be same? So do you all realize this?
Yes.
Now, once you realize this, that the acceleration is going to be same, mentally, not actually. Mentally stretch this mass like this and like this. So once you stretch the mass, you can see there's something interesting happening. The two masses will move in the same direction, right? Can you realize this part?
Yes.
After making the string straight, once I make the string straight, it looks like both are running in the same direction. If I say this is M2 and if I say this is M1, so M2 will move this way and M1 will also move this way with same acceleration, isn't it? You can see this hypothetically. And the tension is TNT. And now you can see the same force which you were applying like this. So there is a concept of called system. First of all, tell me the two masses M1 and M2 are moving with same acceleration in that way, isn't it?
Yes.
Whenever it's your system in which you can sense that acceleration is going to be same in the value at least and in the sense also, then instead of thinking as two separate mass, we can also think as one single mass. So these two masses can be replaced by a single mass. And if I do so, if I replace by a single mass, what is the total mass of this system, guys?
M1 plus M2.
So we know this is M1 plus M2. Very good. And this combined mass is going towards right. So this combined mass can be said to be moving towards right, isn't it? And if this is so, then you can clearly say that the M2 and M1, what they are experiencing as a force, now it will become the pull force, right? Do you realize the pull force? So M2G is pulling right, M1G is pulling left, right? And the tension which is acting between the string, because of the system assumption, we can ignore the tension, isn't it?
Yes.
because it's internal in nature, so we can ignore as of now, and then we can only consider the M2G and M1G. And acceleration we can write easily. What is acceleration? It is a net pull force upon total mass to be driven. Do you all realize this what I'm saying? So acceleration is basically the net pull force upon total mass that this pull force is driving. So what is the total pull force? Net pull force is how much, guys?
M2G minus M1G.
So I can add this as M2G minus M1G. And how much mass you are driving?
M1 plus M2.
And you can see this is your same answer, isn't it?
Yes, sir.
So whenever you have a system in which the acceleration having same value, and if you mentally stretch the string, and if you see after this mental stretch that all are having the same direction, the acceleration you can write directly net pull force upon net mass that you're pulling, the mass which will be in motion. And once you get the acceleration, because that is the first step, and if you really wish to find the tension as well, you can write the ABD of any of the equation, any of the block to get the tension. So you may write M2G minus T equals to M2A. And because we know the A value, you can substitute and you can get back the tension the way you got earlier as well. So for tension, there is no option left. You have to choose one of the block and write the ABD and write the laws of motion and get the answer. So is the method clear to you guys?
Yes, sir.
Now this answer is so famous that I always expect that every student must remember the answer itself. So as a beginner, although it's the first question for you, but to make sure that you have practiced enough to remember the answer itself, not to solve again and again, including tension and including acceleration. So it's a very easy answer. It's the net pull force upon net mass. It's very easy, isn't it? Hello.
Yes, sir.
Just a moment. So imagine if I give you a question like this, and in fact, you will come across. So few more questions will do. And see, I really want you guys to master this chapter because this is the soul of the entire dynamics. It means if you do not know laws of motion, then I mean, no one can help you in understanding physics. So your struggle with physics will continue. So if you want to get rid of the struggle, then it is my humble request. Please do give emphasis to this chapter more than anything else in your life. Master it simply. I mean, see, even the being average is not the criteria. You have to master it. And I will take you to the level. See, it doesn't matter how many lectures it will take me to finish this. But at the end of this chapter, I want you all to master. Because if you all master, then my job is going to reduce by half. So I'm taking it really slow. I mean, generally in 4 lectures, it is totally completely finished. And we are roughly 6 lectures behind. I'm taking it really slow so that you all can master it, grasp it, understand it, realize this. Look at this question. M1, M2, M3. Now, what will happen in this case? The blocks will move in one direction. So all the mass will either go up and down, isn't it? Now, can you say which mass will go up, which will go down? Tell me.
No, sir.
So we have to assume something. So let me give you the hint or the assumption. I'm assuming this side to be going down and this side to be going up. What do you think about accession? Is it going to be same or different?
It's the same.
Rugved, tell me. Is it going to be
Same.
same or different? Yeah, tell me.
Same.
Same. So you realize this, isn't it? It's the same, right?
Yes.
If you realize it is same, so can we treat this as one system?
Yes.
And if you can treat as one system, can you see the net pull force? Can you see the net pull force?
Yes.
So tell me, guys, what is the net pull force here? And how much mass you are driving here? Any guess? Prasansa, tell me, how much mass we are driving here?
Or M1 plus M2 plus M3.
So all three mass we are driving, isn't it? On the right hand side, how much pull force is exerted by the gravity?
M3G.
Is it only M3? Gravity is only pulling M3. What about M2? So we only look for the pull force, the gravity force. And if I consider everything as system, then the tension becomes internal, but gravity is always. So see, at first go, as a beginner, you can also think this way that, okay, this is a pulley, this is one mass. And M2, M3 will move together. So why don't we take as one single mass? It is also same, no?
Yes, sir.
See, gravity will act irrespective of your position. It is not the lowest will get the gravity. Why don't this will explain the gravity? Tell me. So how much is the net pull force on the right?
M2
Tell me.
plus 3G.
M2 plus
M3G.
whole into G, right?
Yeah.
Yes, sir.
And how much force is being pulled left?
M1G.
So what must be the accession? A equals to, tell me Prashant, what is A? So what is accession? It is going this way, no? So accession is defined as, hello.
So
So net pull force,
Hmm?
total mass.
So in the net pull force, how much I should write?
for M2 plus M3 into G minus M1G equals to M1 plus M2 plus M3 into A.
One M1 plus, right? This is what you're saying.
Yes.
Rugved, you understood?
Yes, sir.
Okay. Now if I ask you, find the tension in each string. Let's say this string is having tension T2 and this is having T1. To get the answer for T2, which block is the most suitable block? Whose FBD will give me the answer? Can you tell me? For T2, we should draw the FBD of which block? Of course, we have many choice,
Sir,
but
M3.
yeah. See, you could have done for M2 also because a T2 will come there as well. But M3 is suitable because it will have less number of forces, right? So for M3, the T2 will act up or down? And what is the direction of acceleration of M3? We know the answer is A. So what will be the laws of motion for this M3? Rugved will tell.
M3G minus T2 equals M3A.
Very good. M3G minus T2 equals to M3A. And A you know, right? Of course, there is no need to substitute as of now. I mean, when you get a nice value, you can do it. But here it's okay. So I hope you are getting this question. Is it difficult? And similarly, if you want to find for T1, which block is suitable, guys? Siddhant?
M2.
For T1, which block is best block to draw the ability?
So M1.
Very good. Now, persons are why not M2? Because if you draw M2, the T2 will come, T1 will come, M2G will come. There are three forces. So that will make the
So, but
complication
we
more,
have
right?
calculated the value of T2, right?
Yeah, of course, we have calculated, but what if, I mean, if you do this calculation first? So, of course, you can do it with M2 also. There is no nothing wrong and nothing bad about it, but it's you have to also optimize the way of solving that which can give the fastest answer. Okay. So the T1 is like this, and it is going upward. Even T2 is known to you, a big term will come, right? It's not number, it is a symbolic term. And that will make it again cumbersome, isn't it? Do you realize this, what I'm saying? So T1 minus M1G equals to M1. I hope this is clear to you guys.
Yes, sir.
So let's see some more problem. Now, every problem that you have solved before can be solved now also by this same method. So let me show you this question. Now, again, let's say this is going down. So this is going up. The A will be same here, isn't it?
Yes.
So what will be the acceleration value? What is A here? What is the net pull force you can see? The pull force.
M1G minus M2G cos theta.
M2G cos or sine?
Sorry, sin theta.
Sin theta.
Yeah, so you can clearly see the M1G is pulling right minus M2 sine theta. Okay, G, I'm taking common. And in the denominator, what we can write here? The
M1.
net mass.
M1 plus M2.
So do you all realize this? Yes or no?
Yes.
sir.
So now you can see it was really easy, right? So finding the acceleration was not a difficult job. So similarly, if someone has given you alpha and beta, and had asked you that to find this acceleration as well. So what is A here? A will be how much? 2 will tell. Tell me, Prashant, what is A here?
So 2 mg sine beta minus mg sine alpha by upon 3m.
Very good. So now I hope you guys are getting this.
Yes, sir.
Imagine this scenario. So when you feel like you confident about these kind of question, just let me know. I'll switch to the other problem. Okay? So you should say, okay, sir, this is enough. Now we can do even tougher questions. So again, first of all, do you realize that every mass will have same acceleration?
Yes, sir.
Okay, if you realize that part, can you see the ability of gravity? See, you have to look for the gravity force everywhere because tension becomes the action, I mean, internal force for system, but gravity is not internal. So you have to think about gravity. So what is the acceleration here? Let's say this is going this way. If M3 goes down, M2 will go like this. Tell me guys, yes or no? If
Yes, sir.
M3 goes down, M2 will go that way and M1 will go this way. Am I right? Hello, hello, hello.
Yes.
So what is the acceleration here? Tell me. Tell me guys.
So 1 second.
Yeah, it is done. Tell me.
So give me 1 minute.
Everyone, please solve and tell me.
Got it, sir.
Yeah. Yes, Siddhant, you can tell me.
Yes, sir. So acceleration is equal to m3 minus m2 sine theta minus m1 whole into g upon m1 plus m2 plus m3.
Excellent. So are you guys getting the same answer? Yes or no? Rugved,
Yes, sir. I got.
you got the same answer?
Yes.
Are you sure?
Yes.
Yes. Very good. Prashantha, you got the same answer?
No, sir, I didn't understand.
Again, see, I mean, are you mugging up the question or you're trying to understand the question? What is happening? Tell me. Do you simply mug up the way it is written? Or do you understand what is happening?
Sir, understand.
So can you see the forces? Okay, can you see the gravity force on each block?
Yes, sir.
Yeah. You can see now. So tell me, like, which force will support the accession and which will oppose the accession? Tell me.
Your M3G will support
And
and um,
so you can check every block and check their gravity force and just check whether it is opposing or supporting the accession at their respective place. The direction of accession of M2 and its gravity, are they supporting? Are you sure? Or opposing?
sir, opposing.
So it will even have to subtract, no? Because it's opposing.
Yes, sir, got it. With the
Got
answer.
it?
Yes, sir.
So you all have understood this, guys?
Yes, sir.
Now let's say if I say the tension on this side is T1 and this side is T2. So to get T1, the ABD that we should draw with minimum effort. So which block ABD is most suitable here to get T1? Tell me.
So m3.
That's correct. So for TN, you must do the ABD of M3. So do you all realize this part that this is the most suitable one? Tell me, guys, do you all realize this part? Yes or no?
Yes.
And of course, you can substitute. And for T2, what should be the which block we should draw the ABD?
M1.
M1, very good. So what will be the laws of motion, Rugved, for this block? The laws of
T
motion will be
minus M1G equals M1A.
very good. Okay, I'm not saying to solve, but keep in mind. So you all have realized this part, how to solve question like this. When the accession is same, we can solve the question, which is right. Hello, isn't it?
Yes.
So let's solve this question. So what is the axis in here? A is how much? You can choose anyone bigger and anyone smaller. Let's take this way. So what is the A? Tell me, Rugved, what is A here?
M1 M1G minus
First see the diagram, okay? See the diagram and then tell logically. Keep your eyes open, right? I think your eyes are
M2
open, mind is shut. Eye and mind both should be open. Observe, answer. Observe, answer. Not tell.
M2 minus M1 M2 minus M minus M whole into G by M1 plus M2 plus M.
Is your mind open?
Yes.
No. You're not. See, there is a problem. What is the problem? I will tell you. What you're doing is you're trying to replicate the pattern. You're not applying your brain. You're not thinking actually at all. That is the biggest problem. So your brain is shut. You are in a race to mug up some pattern. Okay, this is done this way, so I'll say this way. And there is no realization. It is so bad situation. You're not able to realize the FBD. Do you see the ABD first?
Yes.
Can you draw the ABD for every block? So you draw the
Yes.
ABD and send it to me first. Okay, do it first. Okay, guys, you all draw the ABD and send it to me quickly. Only 30 seconds. Send it to me really fast. Okay, person, where is the normal reaction for the block M? Can you draw the normal? It is having the surface contact, right? The small m is touching the table, so it will experience normal reaction as well, isn't it?
Yes.
Yeah, that's correct. Very good. Yeah, where is the ability?
Sending.
Do it very fast. Do it fast. So don't send me the ability, complete ability. Nothing to be missing. So when you draw the ability Siddhant, you must draw the name. I mean, the upward force on M is normal N, which is of
Yes.
course equals to numerical MD, but that is not a way of showing, right? Okay. T1, T2, fine. N into T1, T2, and T1, find the both. That's correct. Now, if you know the ABD, can you see which all forces support or oppose the acceleration? The mg of the small m, is it supporting acceleration or opposing acceleration? Tell me. Mr. Raghuvat, tell me. The gravity force on the small m, what it is doing to the acceleration? Is it supporting or opposing?
It it is supporting.
Okay, you don't realize support and oppose, right? Okay, is it pulling it?
No, it is not pulling any.
Is gravity trying to pull you right or left?
No,
So how it is supporting?
that was what I thought at first, but
So will you
then
change your
had a-
will you change your mindset now? Will you say something else? So what is the role
yes,
of
it does not
mg?
do things.
Exactly, it is doing nothing. So not telling what is the net pull force. So the net pull force is how much?
M2G minus M1G.
Very good. So that's why I say keep your mind open. Don't say the answer when you solve one question. It is a very general tendency. When you solve one question, you try to kind of replicate the process. Even in examination, I have seen that many students, they don't solve, they try to recall what I did there. So the entire creativity or thinking ability become redundant. So they become a mugger. They simply mug up things. Okay, what about the denominator? What is, which mass is moving or getting pulled here? So the
All the
mass to be pulled here
are
is all
getting
mass or
pulled.
only M1 M2?
So all masses.
I hope this is clear to all of you guys.
Yes, sir.
Yes, sir.
So similarly, if I give, if a block is kept on a horizontal surface, it cannot, the gravity on that surface cannot do anything. It will never assist or oppose the motion, isn't it, guys? That's
Yes, sir.
logical. So gravity is not going to assist because the motion and the gravity are mutually perpendicular. So there is no question of component, right? So what is the accession here? What is A here?
2mg by 3m.
That is equals to?
A.
So that is 2 mg by 3m means what?
Okay. 2g by 3.
So I hope this is clear to you, all of you guys.
Yes, sir.
So now let me raise the level slightly. I'll come to the chain problems. So if you have seen a chain, the chain will have mass over its length. So it's not like a point mass. Rather it is distributed mass over the length. So now let me do the chain. And this chain is kept on a smooth frictionless surface, right? The mass is m, length is L, and mass m is distributed over the length L. Is this clear?
Yes.
So mass M is distributed over the length L. This is the chain. To allow the chain to start falling down, we have to pull at least one link, right? So if you pull it slightly right, what will happen? Will it start moving down?
Yes.
Tell me, guys, yes or no?
Yes, sir.
Yes, sir.
Okay. So the pull force will depend on which mass? The mass on the table or the mass hanging? Tell me.
So hanging.
But here the hanging mass will keep on changing because as it will fall down, we will have more and more hanging mass, isn't it?
Yes.
So it means it's going to be a variable pull force. The pull force earlier was constant, right? We have M2G,
Yes.
M1G, and whatever. But now, do you realize that the pull force will vary over time? Do you realize, guys,
Yes, sir.
that the pull force will vary over time? Yes or no?
Yes.
No. So if you realize this, so how we solve such problem? So let me make it simple for you. So this is the in the very beginning, but after some time, you have to assume some value. And this is going to be a variable. So the way to attempt such question is you have to draw a diagram in which you will be showing a part hanging. So the hanging part you can call as X. So what is the part on the table?
L minus X.
Very low. Now if X part is hanging, so what is the pull force here? So what will be the pull force? The gravity is going to pull by what force? Tell me. So for that you
So
need to find
mg
the
by
mass
x.
of the, pardon?
Mg by x.
Mg by X. What is mg by X? Huh? So you can say anything you want, right? Again, you have also become the blind again. This is the blind way of saying things. So how to find the pull force? For that, what you need to know first? Tell me. To find the pull force, what you should know first? Tell me.
So mass of the chain hanging.
So what is the mass of the chain hanging? Tell me first.
XM by L.
Yeah, this is Xm by L. So you know the mass of the hanging chain. So you know the pull force now because you know the mass. You can find the gravity also. So what is the pull force? Tell me. What is the full force? Tell me.
Sir,
mg
XM.
x by L.
It is mg x by L, right?
Yes.
Yes.
So any chain problem, there is a simple statement. What we call is driving force equals to driven mass into acceleration. So driving force you got is how much? mg x by L. Am I right?
Yes, sir.
Okay. How much mass will move because of this pull? The entire mass or only hanging mass? So the entire mass will move as a
Entire
single
mass.
system, right?
Yes.
Entire mass will move as a single system, isn't it?
Yes, sir.
So the driving mass, driven mass is the entire mass. So M will get cancelled. So how much you are getting A, guys? And you can see something that the acceleration is a function of x. Can we use kinematical equation here? Find velocity. Can we use v equals to u plus at s equals to u2 plus half t square or whatever? Yes or no?
Yes, sir.
No, sir.
Siddhant, can we use? Rugved, can we use? If yes, why? If no, why?
So we can't use, right?
Yeah, we can't use. So why we can't use?
Because acceleration is variable.
Exactly. So all the standard kinematical equation is only for the constant acceleration, isn't it?
Yes, sir.
So here is acceleration constant or is function of something?
It is
Function of
function.
x.
Yep. So because it's a function of x, we cannot use the kinematic equation. So if you wish to find the velocity of the chain as a function of x, as a function of hanging mass or hanging part, you have to use the calculus. So do you know how to use the calculus? I mean, how to solve this differential equation? We have done this before in the kinematics. Anyone remember that? No. So do you remember the way of solving? Tell me, guys. Hello, hello, hello.
So by integration.
Yeah, so do it, tell me the answer. If you have answer, you can answer it. So when accession is function of x, then which relation we use for accession? Do you remember? The A must be replaced by. So how we write A? Tell me, guys.
So v dv by dx.
Very good. We write V dv. And we got this equals to gx by L. So V dv is how much? And the next step is integrate both sides. So when x was 0, what was V? It was also 0. So the answer is how much? V square by 2 equals to G by L. X square by 2. So V turns out to be how much? See, if you have studied kinematics, then it will be the secondary calculation in all such problems. So you have to first do the acceleration, Once you realize that A is variable, you have to do the variable acceleration concept, apply the variable acceleration concept to find the velocity, and so you can find something else also. So I hope this is clear to all of you guys.
Yes.
So do you realize that how to solve question? Yes or no? Hello, hello, hello.
Yes, sir.
Now, this is what you have to learn. How to think first, how to assume variable, because here you can easily understand that chain will fall, so the hanging mass will keep on changing, and accordingly the answer will come. So imagine if I give you a pull.
So can you show the previous slide for 1 second? That's it.
So now the chain problem, if I create this way, imagine and the chain problem you can also think as the heavy rope problem. So instead of chain, you can think as a rope is hanging with some mass. So now you can see there is a chain. Ignore the dimension of pulley. Ignore dimension of pulley, which means assume the radius of the pulley to be like a thin nail is, kind of hinged into the wall and a chain is suspended. Then can we assume without any loss of generality that the L/2 and L/2 will be same on both sides? Can we assume? So at equilibrium, the equal length will be on both sides.
Yes.
Okay. So now what you are supposed to do is you can assume the the mass is uniformly distributed. So I will introduce a term called lambda or something called the linear mass density. That's called lambda. So the lambda is basically the mass per unit length. And why we use lambda? Because writing m by l is not convenient. So we write lambda because anyway lambda is going to be constant here. So lambda you can write as dm by dx or whatever dx. So to write a mass, we can write lambda into dl, or simply for uniform, you can say lambda into l. So once you know the length, you can express the answer. So now initially it's, equal length on both sides. So what is the acceleration now? So right now the acceleration is 0, isn't it?
Yes.
So what will happen if I pull slightly down? So let's say now this side is pulled down by x. If you pull this by x value, so let's say x is the chain is pulled. In a way, it's like you have pulled slightly and released. So as it will fall down, the the pull force on the two sides of the pulley will change, right?
So is x the length?
No, no, X is the pull part, like how much it has descended. After time t, it will descend, right? See,
Yes.
you pull slightly, like you just pull the one link. And once you pull the one link and release, what will happen? It will automatically or on its own start falling down, right?
Yes.
So let's say after some time t, the right end has gone down by x. So the left end will go up by x, isn't it?
Yes.
So you're supposed to find the acceleration of this chain as a function of x. So find acceleration of chain as a function of distance, which I'm calling x, descended by a right part of chain. Okay. So tell me, guys, what should be the answer? So what will be the net pull? See, you're supposed to find the net pull force again. And then the same process. Net pull force equals to mass into, driven mass, the mass which you're driving into acceleration. So think about it, spend some time, at least 1 minute and 1.5. And then give me the acceleration and also find the velocity of change as a function of x. Also. Keep your eye, brain both open. Think carefully, attempt accordingly. Then guys, tell me how to find the net pull force. So you can think the entire chain on the right as the right block and the chain on the left as left block, find their masses, find their gravity, and then we need to subtract them, right? Because both are pulling in opposite sense, kind of opposing, right? Yes, Siddhant, tell me the answer.
So will we get the answer in terms of x?
Of course, answer being X only. Na? So what is the net pull force here? It is very easy to write the mass lambda into the length on the right or length on the left. On the right side, what is the length after some time t? The total length on the right is how much, guys? L by 2 plus x. Okay. So the mass will be lambda. Lambda is mass per unit length. So this much length. So the pull force is into G. The left will oppose lambda into L by 2 minus x into G. Net pull force upon net mass. Net mass is how much? None of you realize this, right? Hello, hello, hello.
Got it.
Got it. So the 8 turns out to be how much? Tell me. So it's 2gx by L, right?
Yes, sir.
And you know how to solve, no? So what will be the velocity? Tell me. What is V? So velocity as a function of x, if I release from rest. Come on, guys, come on. What is happening? I'm taking so much time.
So root of
Velocity will
2g
be
by
root
Pardon?
2g by lx.
yes,
Root like this, right?
Yes,
yes.
sir.
Okay. So when the entire chain will fall, I mean, when the all of the left chain will, I mean, or you can say when the chain will leave the pulley at the instant, at the instant chain leaves the pulley. So if all chain will leave the pulley, then the x will be how much? After how much descent the chain will leave the pulley?
L/2.
L by
Very good. So at that instant, what will be the velocity? You can take L/2 inside, which is L square for the answer is GL/2. Is this clear? How the answer is? Hello, hello, hello.
Yes, sir.
Yes.
From the chain problem, this is the last problem. This is called the step. And the chain is suspended from the step actually. It's like a staircase. So the size is h. And the total length is L. In this program, there is a concept which is called dead chain. Which means the chain which will fall on the lower surface will become dead, or you can say immovable, which means it will never be part of neither the part of a driving force or nor the part of driven mass. Do you realize what I'm saying?
Yes.
So after some time t, the chain which will fall on the surface, lower surface, will become dead. So and let me show you the dead chain by this red color. I mean, of course, let's say x length of chain is dead now. This will remain h. So what is the chain on the topmost, top of the table? What is the length of chain here? Tell me, guys.
L minus h plus x.
Like this, right?
Yes.
Okay. Anyway. So now the mass falling on the lower table surface is the dead chain. So it will not move or will be part of any movement. It is not going to do anything. So what you realize that as the mass, as the chain will keep on falling, the driven mass will keep on changing, isn't it? Hello, hello, hello. Now the word I'm using is the driven mass. And driving force. So here the driving force is what? Who will drive the entire chain system? Tell me, guys.
So the hanging.
The hanging part only. Is that part constant? I mean, at least till the chain falls off the table,
Yes.
that part is constant.
Yes.
Which means the driving force here is
Constant.
constant. If the driving force is constant, and the driven mass is,
Variable.
because every time a chain will fall on the lower surface, it will become dead. So now we need to pull or drive lesser and lesser mass. So this is constant here. And but the driven mass is variable. Earlier in the problem, the first problem, here the driving force is variable, but the driven mass is constant. So what we are driving is same all the time, isn't it? Hello.
Yes. Sir.
So can you solve this question? Find the axis. What is A here? Always think of driven, driving force, driven mass. Driving force, driven mass. Okay. You cannot say m by 2. So you have taken the mass on the left as m by 2 and you multiply with L by 2 plus x. For what reason? Mass is mass.
Sir, I assume that if length was half, then mass also got half.
But the length is not half. Length is variable. Na? What is the length of the left side?
L by 2 minus x.
And right side?
L by 2 plus x.
So how you can multiply length with mass? That is itself meaningless, right?
Yes, sir.
So cancel it. So you understood the mistake, no? What you have written is, actually you have written mass into length, which is of no use. There's no physical meaning here. Why you would multiply mass with length? For what reason? We are multiplying lambda into length. Lambda is what? Mass per unit length. Understood?
Yes, sir.
So you understood your mistake?
Yes, sir.
Yeah. So what is the driving force here? How to write driving force?
So lambda h g.
Lambda into h into
G.
what is the driven mass? Come on, tell me what is the driven mass? How much mass you're driving? If X is the dead mass, then what is the live mass?
L minus X.
Simple. So the driving force equals to the driven mass into acceleration. So 8 turns out to be how much? So find the velocity as a function of X. Tell me guys, what is the velocity?
So is it V is equal to minus GH log of X minus L?
So the limit of integration you have done carefully. So V dV by dx. So V dV is so when X is 0, V is 0, when X is X, V is V. So answer is, and here the answer is ln L minus X. If you put X, you'll get X. If you put 0, you'll get ln L, right? Do you realize this? So this is basically ln L by L minus X.
Yes.
Is this clear, guys? Hello, hello, hello.
Yes, sir.
Yes, sir.
Understood?
Yes.
Okay. So now we're done with the chain problem as well. So now comes the spring problem. Okay. So we haven't discussed a lot of spring question. So as we have seen that when the two masses are connected with a string, with a thread, we assume that threads are inextensible. It means you can't stretch it. And because the strings are inextensible, it puts constraint on connected masses. So when two masses are connected by a string, it is going to affect the motion of each other. So the motion of both can't be independent. One will decide the motion of other and vice versa. But if two masses are connected by a spring, the spring is stretchable. It can be compressed, it can be elongated. And it's because the spring can be compressed or elongated, the idea is simple. The connected mass can move freely. It means it will not impose any constraint. And therefore, it is quite possible that the two connected mass with a spring can have different acceleration. So we are not supposed to think that they will have same acceleration as we have seen in case of string. Is this clear? So imagine a situation. We have two blocks connected with, of course, string. Okay. So, if I apply force here, there is no guarantee that, I cannot say that M1, M2 will have same acceleration. So you may apply force here, something else will happen, I don't know. But let's say I give you a situation that F is applied on M2. And I'm telling you that M1 is accelerating with A naught. So it's very interesting. What I have given you force on M2, what I'm saying that M1 is accelerating with value A naught. Can you find the acceleration of M2? So find the acceleration of M2. I hope the question is clear. Tell me, guys.
Yes.
Okay, seems like you are confused, no? So tell me, if block M1 is accelerating, it means it must be experiencing some force, isn't it?
Yes.
Can you tell me how much force M1 must be experiencing? The net force on M1 is how much? The Newton said third law, you know what is third law, I mean, sorry, second law. So what is net force? Net force equals to? Hello. Net force equals to? What happened to you guys? F equals to?
Kx equals m1 a naught.
I'm saying, what is the definition of net force? F net equals to?
Mass into
Mass into
acceleration.
acceleration.
So M1 mass, you know its action. So can you tell me what is the net force acting on M1?
M1, you know.
So force on M1 is how much? M1 A naught. Do you realize this? Yes or no?
Yes.
And tell me by your common sense, who must be applying on M1? And who will apply? Come on. You
Spring.
have common sense? You don't have. I can do that. Who will apply force on M1?
The string.
The? You said
So
string
it's
or spring?
spring.
Spring.
So a spring will apply force on this. So to apply force, a spring will apply force on M1 towards the right. So is it pulling or pushing?
Pulling.
So it means the spring is under stretch or compression. So the spring right now is elongated or compressed. What do you think?
Elongate.
Correct. So now, because of this answer, this is the spring force. So, and this spring force is acting this way, right? So if the spring force will act this way on M1, then how the spring force will act on M2? Tell me. So the spring force on M2 will be right or left?
Left.
Left. Very good. So the spring force on M2 is left. And because all forces acting on M2, can you find its acceleration? So what is the acceleration of 2? At least say the answer. Come on, don't remain quiet. This is really bad.
F minus
So
m1 a
F
naught by
minus
m2.
M1 A naught by M2.
Very good. So do you all wait for each other turn? Like who will say first? Who will say first? And if it is so that you wait for others to speak first because you may be wrong, then you're learning with fear, which means mentally you are very conscious about what others will think. And that is really not good for learning. Learning is always shameless. I mean, you should not ashamed of asking question, answering question. If you're very much conscious that, okay, you must be answering correct only. If it is wrong, then you will lose your confidence. Then it's a wrong, you can say, kind of conditioning. So as a student, we should ask without any fear. Even if it makes you a laughable stock, that's okay. Just Okay, questions clear? It's the same question.
Yes, sir. Got it.
Yeah. So what's the answer?
So F plus MA naught by 2M.
So A equals to A plus, and this is the right answer. Because the M is M is moving left, so the spring force must be pushing it, right?
Yes, sir.
The same will happen on this side also. And we know the spring force must be MA not, right?
Yes.
Okay. So we'll go back to the cutting of a spring part. So the question will be find the acceleration of the masses just after it is getting cut. Let me put as a heading. So imagine From the ceiling, we have many spring, many block. If these two masses are suspended and if everything is at rest, can you tell me how much is the spring force developed in the upper spring and how much spring force is developed in the lower spring? Can you tell me? Am I audible, guys?
Yes, sir.
Yeah, still.
So could you repeat the question?
What is the spring force developed in the upper and lower spring? Okay, guys. So K1, K2, see, I'm asking simple question. What is the, I mean, can you draw the ABD of this M1, M2? Can you draw the ABD? Free body diagram? Now,
Yes.
each spring will elongate or compress? Logical question.
Elongate.
Or elongate only. So, you know, all is going to elongate. So what is the ABD of the M1? So if if K1 is elongated, I mean, then the spring force will be upward K1 X, or you can simply say F SP1, or what, like that's it. You can say whatever you want. The gravity will pull down, and the spring which is below is also elongated. So it is K2 X2. Let's call K1 X1. And because the spring force is action reaction pair, so it will also pull it. If you are if the lower spring is pulling M2, it will also pull M1, right? So if you want to say, let's say this is F1, this is F2. And for equilibrium, what we can write? For equilibrium, what we can write? F1 equals to M1G plus, that's called F2, right? This is easy to write. So for M1, can we write the net for 0 like this? Tell me yes or no. And similarly, the F2 will be equals to M2G. And if you substitute F2, how much F1 you will get? Tell me. So you can clearly see that the spring force in that above spring is M1 plus M2 into whole into G. And that you could have thought as a single mass suspended from the K1. So K1 is holding the weight of these two blocks, isn't it? Do you realize this? So the first spring is holding the weight of the entire mass. Hello, hello, hello.
Yes.
So the first spring force must be the total weight of the masses, right? But the second is only holding the lower weight, isn't it? So the second spring force is equal to the weight of the lower mass. So either you can draw the complete ABD and get the answer, or you can do by common sense. Do you realize this? Hello, hello, hello.
Yes, sir.
Yes.
So the upper spring is holding the entire hanging weight, no matter what you connect in between. The entire weight is being, supported by the upper spring, and the lower spring is holding the weight of the lower block. It is clear? Okay. So now what I'm going to do is I'm going to take points A, B, C, and D. So if you take 4 points A, B, C, D, and if I make a cut one by one. So when I'm cutting the A, then I'm not cutting B, C, D, and when I'm cutting B, I'm not cutting, of course, others. So let me make a table. So let's call this is M1, this is M2, A, B, C, D, which means if I cut at A, what will be the acceleration of this A1, A2? So I would like to find the acceleration of A1, A2 just after you cut. Now, what I have said that in the last lecture, that when you cut a spring, the spring force remain intact. Okay. Because the spring force cannot change immediately. If it is acting by some force, that force will continue to act even though you cut the other end. Okay. So for example, for M1, when you cut at B, you remove the spring. So that's a different story. But when you cut at A, you don't remove the spring. For the B, I mean, when you cut at A, the M1 will still experience the same spring force as before. Understood? So when you cut at A, M1 will still experience the spring force due to K1 as before. Do you realize this what I'm saying?
Yes, sir.
When you cut at C, what will happen? M1 will not experience the spring force due to the lower spring, isn't it?
Yes.
But M2 will still experience the spring force due to the lower spring.
Yes.
So you're supposed to tell me the acceleration just after cutting at A, cutting at B, cutting at C. So let's start with the A. When you cut at A, the M1 will keep on experiencing same force as before, isn't it? Hello, guys. When you cut at A, the M1 will keep on experiencing same force, yes or no?
Yes, sir.
Yes.
So the acceleration, because it is at equilibrium, so the acceleration will be 0, isn't it?
Yes, sir.
And nothing is happening to M2 also, so the acceleration is again 0. Okay. Now, when you cut at B, from the life of M1, which force will go away? Okay, so how much force will decrease?
The spring constant.
No, no. When you cut at B, you remove the top spring, right?
Yes.
And how much top spring is applying force? You know the answer? What is the force applied by the top spring in the beginning?
K1 X1.
And what is that K1 X1? My God, you can't see. I mean, I have solved it here. What is K1 X1?
M1 plus M2G.
See, the upper spring is holding the weight of the M1 and M2 both. So it is applying force equals to the weight of both the masses, which is M1 plus M2 into G. So first you need to see this. Once you see this, if I cut at a B, then from the life of M1, how much force we are decreasing?
F1.
F1. So what you remove is the net force, understood? Because earlier it was at rest. So what F1 is applying, the same is applied by others, which simply means when you cut at B, what will be the net force on M1?
F1.
F1 itself. See, what force you reduce is the net force. Understood what I'm saying? Hello, guys.
Yes, sir.
Yes. Sir.
So what is the net force acting on M1? F1, right? Come on. When you cut at B, then
Yes,
what is
sir.
the net force on M1? It is F1. So what will be the acceleration of M1? So immediately after the cut, what is going to be the acceleration of M1? Use the Newton's law definition. Acceleration equals to
Force by mass.
So G.
how much you said once again?
G.
G?
So GG.
GG. See, how much is force on M1? Net force on M1 is how much? What is the
M1
net
plus
force on
M2G.
M1? M1 plus M2 into G. And how to find acceleration? Net force upon?
Mass.
So mass of M1 only, na? This is the net force on M1. So the acceleration will be net force upon mass. That's it.
Okay, sir.
Hello, hello. And therefore, okay, now M1 will go downward or upward? It will
Down.
accelerate downward, right? Why? Because when you remove the top force, it will go down. If you remove the bottom force, it will go up. Now, what about M2? Is there any change in the life of M2 by cutting the spring at B?
No.
So what will be its acceleration? Hello, hello, hello.
So 0.
Very good. Now, similarly, tell me about C. When you cut at C, how much force will decrease from the life of M1? Like how much force you are removing?
F2.
Cutting at C means you are removing F2.
Yes, sir.
So F2 means how much? F2 is equals to?
M2G.
And now it will accelerate upward or downward? It will accelerate upward, no? But even though you are cutting at C, what will happen to the life of M2?
Will stay the same.
When you cut at D, what will change in the life of M1? See, you're cutting at D, which means both these springs are still connected to M1. Hello, hello, hello. If
Yes.
you cut at D, then both these springs are still connected to M1, isn't it?
Yes,
Yes.
sir.
So all forces remain intact.
Yes.
So the block M1 remains at rest.
Yes. 0.
But for M2, once you remove the spring, it will be only under gravity, isn't it? So it will simply free fall. Hello, hello.
Yes, sir.
Yes, sir.
Or you can think this way that the force you are removing is F2. So F2 upon M2 is how much? G only.
G.
And it will go downward, that's it. So is this clear how we are cutting? Hello, hello, hello. Is this clear, guys?
Yes.
Yes, sir.
Yes, sir.
Okay. See, spring questions cannot be answered by writing so many questions. You have to think logically and organically. So in laws of motion, every challenging problem requires tremendous thinking. So it is not about equation, it is about thinking actually. So equation wise, it is only one line. But to reach that one line, you have to think carefully about everything in a logical manner. Okay. Now this is slightly difficult and challenging, but nevertheless worth solving. Now I'm also introducing a string to make this more interesting. So now you can see there are three, there are two springs, but there is also one string, a thread. A thread cannot be extended or compressed. So the property of tension is it can change almost immediately. It can change almost immediately. Understood what I'm saying? So what we say about spring, we cannot say about string. String can change its tension, its force value almost immediately. It will react to change almost instantly. Spring cannot react to change almost instantly. There is the difference. You have to remember that. Let me put this in writing also. String react to change in condition almost instantly. But spring cannot react to change in condition instantly. So theoretically, you must remember this fact. Okay. Now, if I cut at A, what do we expect? Will there be any change in the life of M1, M2, M3?
No.
Yes, sir.
The answer is no. And in fact, there is very interesting thing. The string will be still unaware that spring is cut there. Because unless M1 will not accelerate, unless M1 is not trying to move, the string will remain intact in the same fashion with the same force. So cutting at B is very interesting point. So when you cut at A, then every block will remain at rest. So that's not an issue. One by one, if you draw the ABD, if you think in terms of hanging mass, the topmost spring is holding how much weight? So if the spring force here is F1 and if it is F2, can you tell me what is F1 and F2? F1 is how much? How much weight you're holding? Common sense. Hello, hello, hello. Come on,
So
what
when A is
happened?
cut,
No, nothing is cut right now. Before you cut anything, so both the springs are at rest, right? Both the springs are at equilibrium. The entire system is at equilibrium, right? So before you cut anything, what is the force F1 and F2? How much is the spring force, the top spring force? Can you guess? Hello, hello, hello.
so M1G.
Very bad. See, the top spring is holding how much weight? Which system it is sustaining there? You don't realize? Indeed, you're not realizing.
So M1G plus M2G
That's
and
it.
M3G.
I mean, you realize gravity. So if let's say if I pack this into one shell, will you be able to see the internal structure?
No, sir.
But still you will experience the same force. Because gravity as a whole is pulling by what force? The entire weight of this system is supported by the spring. No? Do you realize this? I have explained this many times. Come on, guys.
Yes.
The top spring is going to, hold this entire system stationary. So F1 must be equal to the total weight. See, that's the simple rule. The spring force will be always equal to the total weight hanging from there. Everything below is actually due to the top spring. Do you realize, yes or no? Not realizing, as I can feel. Are you guys realizing what I'm saying?
Yes, sir.
Questions are telling.
Yes, sir.
So tell na, come on, why you're silent? Siddhant, are you realizing what I'm saying?
Yes.
So the top spring is holding how much weight?
M1 plus M2 plus M3.
The entire weight, no? What's the problem? Why you're not able to realize this? Similarly, what about F2? The lower spring is holding how much weight?
M3G.
And right now, if I ask you the tension, how much tension is holding the weight? What is T before? So what is the T? How much tension is holding the weight? What weight T is holding?
M2 plus M3G.
Very good. So gravity is pulling both, and it is the tension which is actually responsible for holding it. So this is how we analyze. Now, what I said is, the moment you cut, the tension can change almost instantly, immediately. Other force we don't know. Okay. So if you cut at A, what will happen? If you cut at A, what will happen? Tell me.
Nothing changes.
Nothing will change. So all masses will have the zero acceleration. So I can say A1 equals to A2 equals to A3 equals to 0. Isn't it, guys? Hello, 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 hello,
Yes, sir.
hello, 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 hello. Okay, fine. Now, if you cut at B, that's interesting. That is the only thing we have to discuss actually. So these are the acceleration. Immediately after the cut. So if you cut at B, try to analyze things. If you cut at B, from the life of M1, what has gone? How much force we have reduced from the life of M1? How much force? Come on.
F1.
You guys are very lucky. I mean, you don't say anything. How someone will teach you if you remain silent? It's very irritating for teacher when no one responds. Either if you're not getting it, say I'm not getting it. I will explain again. If you understand, then make sure that you all respond. It is clear? So when I cut at B, how much force will go away from the life of M1?
Sir, F1.
F1.
F1. But this is the first part you realize. The second part which you don't realize, the tension, because F1 is going away from M1, so M1 will try to accelerate. And the moment M1 will try to accelerate, the T will change immediately, which means not only F1, even the T will change to a new value T dash. So that is a difficult situation to deal with. That's how we can solve them. Because now M1 will not experience T, it will experience T dash, a new value of tension. Okay. So when you cut at B, so upper force, force due to the upper spring, force due to upper spring will go away. Understood? So what will happen here is, and how we deal with such question, like when we know that okay, the upper spring is now going to move, so the upper block is going to move. The moment the upper block is set into motion or is about to move, and because M1 is directly connected with the string, so this tension will change immediately. Are you getting my point? What I'm saying? And as T will change to T dash, the M2 will also lose its equilibrium. Hello. So M2 will keep on receiving the force F2 and M3G. I'm sorry, M2G. So we can draw the ABD of the system connected with the string. And if you look at the system which is connected with the string, we have M1, we have M2, we have F2 acting at the bottom, and we have M2G. Understood?
Yes, sir.
So the force at the bottom will continue to act. F2 and M2G will keep on acting. That will not change. Understood what I'm saying? So this is the ABD you're supposed to draw. But because the top force has removed, so both system as a whole will accelerate downward. Both will accelerate downward. And tension will put like this, it will go down. So the M1G will also there. So now you are supposed to write the equation for M1 and M2 with the new tension value. So we can write as M1G plus T dash equals to M1A. And we can write for M2, what we can write? F2 plus M2G minus T dash equals to M2A. Do you realize this?
Yes, sir.
And therefore you can see clearly, if you add both the equation, F2 is actually M3G, right? If you look carefully, it is actually M1 plus M2 plus M3G equals to, on the right side, it is M1 plus M2 into. So the new accession that they will have is what you don't realize, that this we could have solved directly, because we know when you cut at B, the net force you reduce is F1. So you can see the net force is F1 is, this is the net force, right? F1. And the masses connected with the string will accelerate, because M3 is not going to accelerate. So this part is going to accelerate together, and that's why the mass is written here. And this question is all about realization. Nothing can be taught here. So do you realize this, guys? Anyone?
Yes, sir.
Yes, sir.
Yes, sir.
So you have to spend time, it's not like I have solved and you have understood it. You have to, look at the question after the class also, try to realize this also, analyze, and also keep on doing the and like cut at other point and Tell me what will happen if I cut the string itself. You need to answer many questions. So very soon I'm going to share the assignment. I just need to actually, I think I have just a moment. Let me do it right away. Um, Okay, I'll tell you something. I have shared a, a big assignment right now. You will not jump to this assignment right now. I'm preventing you. Don't do this. Rather, first you solve SC Verma. Once you're done with the SC Verma, now you can start, you all can start solving SC Verma, because most of the questions which you will see in the beginning are very simple and based on what we have studied. Once you're done with the SC Verma, the simple problems in which we have same accession visibly, then only you will have to come to here. And by that time, of course, we will be finishing more. So now your job is to please solve SCRMA first on your own without seeing any online solution, because it's a very common temptation for students, because the SCRMA solutions are available everywhere. They open it and they see it and they think that they have understood. Although it's an easy question, but don't just solve. Spend time in realizing, draw a BD, find the force, write the acceleration, laws of motion, find the direction of motion, do everything as we have discussed, and revise the theory notes again and again. Make sure that when we finish this chapter, you have mastered the concept. Okay.
Yes.
Okay, so hopefully the next lecture will be the constant only. We have done with the basic question, all questions are done. These questions are going to be asked in JEE Advanced and Mains both. Rest is for the rest of the chapter. So rest will be useful in every other chapter which we are going to face. Laws of motion is and the kinematics are something which you use everywhere. So these are not chapters. We have to keep on using it again and again. So now I'm giving you homework that analyze for the other cut. So you cut here and then analyze, cut here and analyze. Okay, so for this and this two cut, you have to analyze and send me the solution before the next lecture. Okay, guys.
Yes.
Okay. Bye and take care. Good night.
Bye,
Bye,
sir.
sir.
Thanks.
Yeah.